let's do an overview of this lab. The first thing you're going to see in this lab is a mixture in an evaporating dish. And that mixture contains 3 different compounds. So the type of mixture that we're looking at, we can classify it as a heterogeneous mixture. It looks like sand. It has sand and salt in it. There's a non-uniform appearance to it. And we know there's multiple compounds in it. The 3 different compounds that are actually in the sample: sand, which has a chemical formula, silicon dioxide. There's something called ammonium chloride, and then sodium chloride. 3 different components. Sodium chloride is the main component in table salt. Now, the 3 together create a mixture. Once we actually separate the 3 samples, we're going to have 3 individual compounds. Notice the notation for the compound. We're using some kind of chemical abbreviation that we're taking from the periodic table. Now, I'm not going to go through the full details here. I'm going to leave that for the lecture videos. What I really want to focus on with this video is the experiment. Let's look at the experiment. Notice there's some information about the individual compounds. Okay, one thing I would recommend is reading through the procedure, at least briefly, before watching the video. And then maybe even having this out while you're watching the video. It may help put some of the pieces together a little bit better. But in the video, I do talk about the experiment and what I'm doing. I don't necessarily reference like part B, part A, etc. The procedure that you see here is basically the sequence that you see on the video. First part is just measuring out the sample and putting it in the evaporating dish. And by the way, there's a photo, there's an evaporating dish. It's just a little like clay bowl. It can withstand a lot of heat. You'll see that in the video. And once I weigh out the sample, the first thing I do is I heat it. Okay, so that's sort of the second part of the video. And there's our component, one of our components, ammonium chloride. And when it's heated, it sublimes. And you'll see that on the video. There's like a white smoke that comes out of the evaporating dish. Sublimation, that definition is above. Let's quickly look at it. It's where something goes from a solid to a gas. Dry ice is another thing that'll do that. Once the ammonium chloride is sublimed away, then we can get the weight. Let's just talk about the data right now, about what's happening here. So, like the raw data that you're going to be collecting in the lab or in the video. First off, you'll see the mass measurement for the evaporating dish. You'll also see the mass measurement for the evaporating dish plus the sample. Okay, remember the sample is this mixture that I mentioned just a few minutes ago. Remember, the ammonium chloride is going to sublime away. And then this is another piece of data, the mass of the evaporating dish plus the sample. Now, at this point, this sample that they're talking about is just going to be the sand plus the sodium chloride. This sample up here is the mixture. Remember, that is the silicon dioxide, the sodium chloride, and the ammonium chloride. Notice one of the data points, the mass of the evaporating dish is just repeated over and over again. It's the same mass. Why is that useful? Well, if I subtract these two, what I determine is the mass of the sample. Again, the sample is that mixture of 3 compounds. If I subtract these two, then the mass that I get there is the mass of this sample, the sand, and the sodium chloride. Now, if this sample contains 2 components, this sample contains 3 components, well, if I subtract those 2, then what I'm going to get, what's left over, that's the mass of my ammonium chloride. Once I have that data point, I can actually calculate the percent of ammonium chloride that's in my sample. And what that's going to look like is, and you know what, I'm going to use B4 and A3 in my equation. So the ammonium chloride, the percent ammonium chloride, that's going to be the mass of the ammonium chloride divided by the total mass of the mixture times 100. What data points are those? Well, the mass of the ammonium chloride, it's B4 divided by the total mass, which is this guy, A3, times 100. That's a classic percent calculation. How much of the sample, what I'm curious about, what I want to know about, divided by the total mass of the sample, times 100. You're doing a similar thing like this for all the other components. And then down here, this is where that data would go, and then I'll just, that would be the percent mass there. And again, you'll do a similar calculation, actually a similar set of calculations for each one of these. Subtract to get the mass of the sand. Mass of the sand divided by the total mass of the mixture will give you the percent mass of the silicon dioxide. I've illustrated one step in the calculation, and it's your job to repeat those patterns for the other 2 components. One thing I want to mention here, one thing I mentioned in the video, is that option 1 we do not do. We do option 2, and I'm going to mark it out in the procedure as well. Option 2 is what we do, which basically what's going to happen, that's your evaporating dish. By the time you get to the end of the experiment, and you'll see it in the video, you'll have an aqueous solution of the sodium chloride in the evaporating dish. You're going to heat it. You heat to dryness. You have the evaporating dish. And then here, this would be solid sodium chloride. So what you do, mass of evaporating dish plus the sodium chloride. Right? You'll see a mass of this in the video. That would then go right here. And then just like before, you subtract those 2, you'd get mass of just the sodium chloride in the sample, and then you can use that mass with the total mass of the mixture to then calculate the percent of sodium chloride in the sample. In the video, what you're going to see, I demo the experiment, I talk about the experiment, and then you're going to see the mass measurements on balances. And you simply pause the video when you see those balances. I've made notes in the video. And then you'll just record the specific data points. So I've already shown the check marks where you're going to see data. You'll also see this data. And then, like I said, you'll also see that data. Again, part of your job is to read the procedure, be familiar enough with the procedure, and watch the video and interpret what you're seeing there, along with my explanations. Let's look at some of the questions. This one is actually similar to the lab. We have a total mass. You have the mass of individual components. And then from that, and the percent formula that I mentioned a few minutes ago, then you can calculate the percentages for each one of those. differences between these two mixtures. A little bit more than this, but this has a uniform appearance, this has a non-uniform appearance. The lecture videos can explain more in the textbook. This section is just dealing with some physical changes. I talk about this. This is going to be, looks like the white smoke in the video. And I talk about that. I also talk about that in the video. Yeah, basically what this is doing is it's testing your understanding of the procedure. I think with a combination of the written procedure as well as the videos, these are understandable and answerable. So complete all of those pre-lab questions. And then for the post-lab questions, what this one is dealing with, this one's dealing with like if an error is made. This would be an experimental error. If that error is made, how's that going to affect the calculation for the percentages of the 3 different samples in the context of the experiment? And really, each one of these questions is asking you to consider some error or some problem that could arise in the procedure. And again, it's just laying out these different scenarios. What if not all of the sodium chloride is extracted? Same thing here. How does it affect the calculations? High mineral content water, that's something with salt dissolved in it. We use distilled water in our experiments because it's pure water. There's no salts that can leave deposits on samples to like add weight to a sample. So for this lab, you'll complete the entire lab, pre-lab and post-lab questions. Thanks.